Getting the news used to be so simple. If you saw something on the TV or heard it on the radio, you knew where it had come from. It didn't matter whether you liked the story, the broadcaster, or the content. You knew it had come directly from the broadcaster to you. Then along came social media with billions of people sharing millions of items every minute. Inevitably, and for a variety of reasons, politics, financial gain, or mischief, some of the items we now see are deliberately manipulated. There might be changes in context, intent, or even the content itself. There are hundreds of organisations, from publishers to academics, technology companies, and civil society organisations, all working to combat disinformation, offering tools, training, fact checks, and advice on how to ensure that what you're seeing is what you were intended to see. But once an item is shared, it can be hard to determine its original source and shape. That's where Project Origin comes in. An alliance of 4 organisations from the publishing and technology world working together to find ways to allow the provenance and integrity of content to be checked, helping to establish a chain of trust from the publisher to the consumer. This short demonstration of the Origin proof of concept will show you how Origin can be used to encode and secure a piece of media, how that security can be maintained during the distribution process, and exactly of how this information can be presented to an end user. The purpose of Origin is to do 2 things: allow a user to confirm the publishing source of a media story, and to confirm that the media has not been editorially altered since it was published. To understand how Origin works, let's follow the journey of a media file from its publication to its consumption. First, an Origin-compliant publisher will package metadata describing the media into a manifest. A digital fingerprint of the file is made. It's cryptographically signed by the publisher. The manifest and fingerprint are then uploaded into the Origin ledger. A receipt is returned to the publisher. This package of validation information is then embedded in the media file. As a consumer watches the video, the browser, or ultimately the video player, checks the embedded manifest and receipt. If the manifest was removed or damaged in its distribution, the secondary process takes a fingerprint of the video and uses it to look up the manifest from the ledger. The status of the video, or sections of the video, are displayed in the player. Positive, negative, and neutral symbols are displayed. For the purpose of this proof of concept, we have created 2 methods to securely encode a file. One is through a command line, the other is through a simple web interface. Both perform the same functions. They create a manifest with publisher metadata, cryptographically sign the manifest with the publisher identity, bind the manifest and file together with a digital fingerprint, register the manifest and fingerprint in a secure ledger. It's important to note that the process is very fast. It can be done in line with current workflows, adding only seconds to the processing of a 3-minute video file. This will ultimately be a function that is carried out automatically by the editorial tools and will not require journalistic intervention. Let's see Origin in action. This example is for the encoding of a video file, but the process would work the same way for any file-based digital media: voice, photos, text, or video. Today, there is no common method of securely identifying the provenance or integrity of a media file. We believe this is a BBC video because it has the BBC logo, but how can we be sure? A publisher creates a manifest which describes the metadata associated with a piece of media that they would like to be authenticated by Origin. In this video segment, we demonstrate how a media publisher might create and sign the manifest locally as part of their automated publishing workflow. Next, the signed manifest is then uploaded to the Origin service. After the manifest has been registered in the Origin service and inserted into the ledger, a receipt is returned to the publisher that provides proof that the manifest has been successfully registered with Origin. This is automatically stored with the manifest in the service, and now the publisher can also embed the manifest into the video directly before distribution. This results in a single media file that contains both the content and the related manifest information. Today, publishers of information do not control the path to the audience. A number of intermediate parties can interact and potentially alter a digital file. Some alterations are for technical reasons, such as bandwidth optimization. These are editorially benign and will be handled by having the party that makes the alteration add an attestation to the manifest. When material is compressed or edited or shared, it's easy for that original identity to be lost, and that's been one of our key challenges. We are creating parallel processes with embedded and remote manifests to enhance reliability of the service. Ultimately, the media ends up in front of an audience using a web browser or a dedicated application. The user will be presented with a symbol indicating that the content is certified and has not been tampered with. This will provide an enhanced level of confidence in the media. The symbols used here are initial designs. They will be refined following further user testing. It's also important to note that the positive affirmation is a guarantee of the provenance of the media. It is a symbol of technical trust. With that in mind, let's now look at how our video will be displayed. An important aspect of the Origin project is how to indicate that a media's provenance has been authenticated to the end user. Origin provides a browser extension which indicates if a video has been previously uploaded to the Origin service and matches the signed manifest. We first show how the browser extension indicates that the video's manifest that we have previously uploaded to the Origin service is used to authenticate the video that is being streamed over the internet. The browser extension icon's colour changes from the original, non-active state to green, showing that the video's provenance has been successfully authenticated as coming from the BBC. Because the browser extension has successfully found the video in the Origin service, it can also download the manifest metadata and display it to the user by clicking on the browser extension icon. Sometimes, deeper investigation is required to determine the authenticity of a video or to see the nature of edits made to its content. An Origin forensic tool is being developed for this purpose. During the initial rollout period, there will be many times when legitimate news is carried by a system that does not yet support the Origin standard. In order to prevent false negative alerts, we will have a neutral indication for the user. Here we show how the browser extension demonstrates that the video could not be located in the Origin service. In this case, the icon state switches from the green authenticated state for the first video to the neutral tones for the second video. Now, let's look at what happens if someone alters this video. The Origin Coalition is currently working to create new media and browser standards, which will allow us to identify that a piece of video has been altered. In this final segment, we show how this will appear to the user as the Origin browser extension icon state changes to red to inform the viewer that the media has failed an integrity check. Origin is a proof of concept. We have demonstrated that we can securely attach the publisher's identity to a media file and ensure this has not been altered in transit to the audience. So, what's next? The Origin partners are working to develop this work into an open industry standard that can be adopted for widespread deployment by all media publishers, large and small. We want to keep developing Origin to make it more sophisticated and to work with the social media platforms to use Origin signals to flag and act on problematic content. And we want to get other broadcasters and publishers on board to ensure that we can set standards for this kind of work that can be widely shared for the good of everyone working in the industry and consuming media content. Please join us in this discussion on how we can use media provenance to build a more secure news infrastructure. Thank you.